Some of these questions we already done, like 8.18. Today we need to work on some spring models, spring-based models. Block of mass 2 kg is pushed earlier. I think this we can do 8.18. You can try. You can do it easy. Easy question actually. 8.18. Practically an easy question in this. Block of mass 2 kg is pushed down an inclined plane of inclination 37 degrees with a force of 20 newtons acting parallel to the incline. Remember, it is a parallel to the incline. Found that the block moves down the incline with an acceleration of 10 meter per second square. 10 meter per second square. Block started from rest. Now tell me what is the displacement. Starting from rest, constant acceleration. This is the displacement. Half into 10 into how much time? First second. 1 square. 5 meters. Find the work done. Remember, what is the velocity? Velocity is 80. Correct? This is again 10 meter per second. See, as work energy theorem states, if you don't mention anything, I feel that it is a net work done. Remember, net work done is equal to change in kinetic energy, which is nothing but half into 2 into 10 square. This is 100 joules. Positive work is done. Right. Next. What is the work done by the weight of the block in the first second? In fact, the component is mg sin theta. So work done by weight is mg sin theta into displacement. Force into displacement. mg is 2 into 10 into sin 37, 3 by 5 into displacement 5. 5 cancel. This adds 60 joule. Okay, na? That adds 60 joules. By the frictional force acting on the block in the first second. See, external force is 20 newtons, right? Here, work energy theorem states work done by external force, work done by a non-conservative force, work done by here the conservative force is gravitational force, is change in kinetic energy. You are aware of that. Correct? You are clearly aware of that. So external force does a work of 20 into 5 because here this force is acting in that direction, right? Work done by non-conservative force, no idea. Work done by gravitational force is 60 joules. Change in kinetic energy is also 100 joules. Here work done by gravity is positive. Please see that. This is 100. Cancel these two. So work done by non-conservative force is minus 60 joule. So in fact, I have applied work energy theorem in this case. మీరందరు నోట్స్ పర్ఫెక్ట్ కంప్లీట్ చేశారని నేను పెట్టాను. ఎంతమంది ఇంకా చేయలే? ఎందుకు చేయలే? అదేంట్రా నిన్న మీ దగ్గర నుంచి తీసుకున్న చూడలేదు కాదు, చూడలా. నెక్స్ట్ ఇంకా ముందర రే వాళ్ళందరినీ ఎందుకు వదిలేసానో గుర్తుపెట్టుకోవాలి. లేదు ఇలా కొడతానికి కూడా వెనకాడను. నెక్స్ట్ రే వరుణ్, పూర్తి చేసావా? నోట్స్ అప్ టు డేట్. ఎవ్రీవన్ చివరివాడు అప్ టు డేట్. నూరా అప్ టు డేట్. ఆడపిల్లల రైట్. minus 60 joules. That's it. Any doubts? Next. say a block of mass. No, this is a model related to what do you call reference frame. This is a model related to reference frame. Right. A block of mass m1 moves with an acceleration a12 relative to a trolley as shown in figure. Okay, next. The block is being observed by two observers, 2 and 3. Right. Okay. What do you want? What is the work done by pseudo force as observed by the observers 2 and 3 on the block during time t? Assume zero initial velocities. Fine. What do you want? Work done by 2 as observed by 2 with respect to 2. Okay. Force on one is mass times acceleration of the block with respect to 2. Right. Now you need to find displacement. Displacement of 1 with respect to 2 is half. And by the way, sorry. All right. Displacement of 1 with respect to 2. What is the work done by the pseudo force? Okay, that is okay. Displacement of 1 with respect to 2 is half acceleration of 1 with respect to 2 into t square. Right. With respect to pseudo force on 1 is minus ma2. Right. Now I'm getting into the question. What is the work done by the pseudo force as observed by 2 and 3? Okay. So now I'm answering work done by pseudo force with respect to 2 is minus ma2. Force displacement of 1 with respect to 2 minus ma2 times half a12 t square. Any doubt in this? With respect to 3, pseudo force on 1 is minus ma3. Yes or no? Now, displacement of before that, first of all, 1 minute. Acceleration of 1 with respect to 3 is what you want. This is nothing but acceleration of 1 minus acceleration of 3. You know this. See, acceleration of 1 with respect to 2 is acceleration of 1 minus acceleration of 2. You know this. Yes, sir. So acceleration of 1 can be written as acceleration of 1 with respect to 2 plus acceleration of 2. Now I'm going to use the same. This is nothing but the acceleration of 1 with respect to 2 plus acceleration of 2 minus acceleration of 3. A12 plus A2 minus A3 magnitude వచ్చేసి దీని magnitude why I require all this? Displacement of 1 with respect to 3 రావాలి అంటే ఇది కావాలి. సో దిస్ ఈజ్ నథింగ్ బట్ A12 ప్లస్ A2 మైనస్ A3 టైమ్స్ T స్క్వేర్. So work done by pseudo force on 1 with respect to 3 is minus MA3 times, that is the pseudo force. Displacement of 1 with respect to 3, right? Which is nothing but minus MA3 times displacement of 1 with respect to 3 వచ్చేసి సబ్స్టిట్యూట్ చేస్తారు. ఇక్కడ ప్లేస్ is nothing but half of A12 plus A2 minus A3 times T square. Any doubts? Next. A block of mass M is moving with an initial velocity V0 towards a stationary spring of stiffness constant K attached to the wall as shown in the figure. Find the maximum compression in the spring. Is the work done by the spring negative or positive? See, we will see that work energy theorem. Here, there is no external force, any internal force, it is conservative force. So work done by conservative force plus 0 plus 0. Why? No external force, no non-conservative forces. Anika, in a class, right? This is a change in kinetic energy. So work done by spring force is 0 minus half m v naught square. So therefore, this is minus half m v naught square. Yeah, if suppose the compression is K half m v naught square. If you see that maximum compression is x max, you can write x max in this case as root m by k times v naught. That is a maximum compression in this pipe. Now, what is the work done by the spring? Does negative work here. You know why? Because the mechanical form here it is in K form, is now totally in the form of elastic potential energy. Ante kada? This is totally in the form of elastic potential energy. Right. Any doubt in this? Boys and girls, basic model. Next. Springs మీద కొంత డిస్కస్ చేయాలి. I'll do that. No issues. Particle slides along a track with an elevated ends and a flat central part. See that diagram, everyone? Read the question. They have given the flat part. The entire flat part is friction. Right, no issues. You release it from A. Let us do the work like this. A to B, what is the picture? At A, you have total mgh potential energy. At B, all that is in the form of లేదు అంత గొప్పగా అనిపించిన వాడు లేదు. ఒకసారి నాగేంద్రకి ఫోన్ చేసాం. నీ బడ్జెట్ చెప్తే అది పంపిస్తాను. రైట్. mgh, that is totally as kinetic energy at B. Fine. The problem is, in the process of B to C, you will lose some energy. Why? Friction does negative work. So at B, when you have total mgh energy, by the time you reach C, the kinetic energy at C plus there is a loss one. So what is loss one? This is nothing but, don't write minus here. Already mentioned loss. Mu mg, the length of the path is 3L. This is the last part, which is nothing but 0.2 into m. What is the mass? We take, let us take m as 1 unit. No issues, because when you are taking mgh also, I'll take m was 1 unit. 1 into 10 into 3. This is a 6 joule loss. So in that case, what is mgh? 1 into 10 into height 1.5, which is nothing but 15 joules. So 15 joules లో 6 పోతే మీకు ఎంత ఉంటుంది? So total energy at C is equal to 15 minus 6, which is 9 joules. C2D, D2C, no loss of energy. Again, in the process of C2B, there is a loss. At C, you have 9 joules. By the time, at C to B, sorry. By the time you reach B, kinetic energy at B plus loss 2. What is loss 2? Every time you move, it is 6 joules. So therefore, loss 2 is same as loss 2 also same. So therefore, kinetic energy at B will now become 3 joule. See, remember, B, it won't reach from B. You will at some intermediate stage, see A dash. It will reach A dash. It won't reach A because to reach A, it requires 6 joules. You may ask me how. When it came from A to B, it had 6 joules. If it has 6 joules of kinetic energy at B, it will definitely reach A. But now you have only 3 joules. So it won't reach A. క్లియర్గా అర్థమైందా నేను చెప్పింది? ఇక్కడ దాకా ఎవరికైనా డౌట్ ఉందా? పక్కా? షూర్? నెక్స్ట్. రైట్. Now again, A dash to B, it will have that same 3 joules. But now it won't reach C because loss is 6 joules. The energy is 3. So therefore, now B to E. At B, it has 3 joules. At E, it is totally loss. So therefore, 3 is mu mgx. 3 is mu is 0.2110x. X is 3 by 2, 1.5 meter. So therefore, this is at a distance of 1.5 meter. So after traveling a distance of 1.5 meter, what happened? It will stop. Any doubt in this, please ask me. So I have repeatedly applied work energy theorem indirectly. I don't say law of conservation of energy won't be conserved. So, but you can still apply work energy theorem. You can apply work energy theorem for any forces, conservative, non-conservative, and external. Okay? But law of conservation of energy is strictly applicable only when there is no external force and when the internal forces are conservative. Please remember this. To apply law of conservation of energy, if external must be zero and internal forces must be apply law of conservation of energy, this is the condition. Any doubts? Pakka? Okay. Right. Similarly, we can apply work energy theorem for any type of forces. Next. సరే తర్వాత చూద్దాం చూడండి 8.3. Small ball is placed at the top of a smooth hemispherical wedge of radius capital R. If the wedge is accelerated with an acceleration A, find the velocity of the ball relative to the wedge as a function of theta. So remember, we are working till contact is maintained. See, in the reference frame, these are the two different forces plus normal reaction force, and with all these, we relate to. So I told just now I can apply law work energy theorem. What are the work done by pseudo force? This is nothing but see if it is theta, this part is r sin theta. Got a point? Work done by gravitational force is mg down, and what is the displacement part here? The total is r, and this component is r cos theta component. So what is this amount? R minus r cos theta. Okay. And any other force work done by normal reaction force is 0. Why? Always it is perpendicular. Except this, there are no other, no smooth, no friction. So work done by non-conservative forces is 0. So net work done is change in kinetic energy. So what I am going to do is, what is the net work done? Add all. So which is nothing but mgr sine theta plus mgr 1 minus cos theta is half m v relative square. Now you say I have applied work energy theorem in the reference frame of the wedge. My mg mar, right. Thanks for the correction. AR sin theta. Done. So remember, I have applied the work energy theorem in the reference frame. So there is no rule that there is no restriction that you should apply work energy. You can apply work energy theorem in, we can apply for any type of forces. We can apply work energy theorem in any reference frame. Any reference frame, either in inertial or non-inertial. Okay. Suppose if I am applying in a non-inertial frame, I have considered the work done by the pseudo force. That's all. I have done the question. So V relative is nothing but that's the deal. Any doubts? Pakka? Sure? Right. So next. Say similar model. Hello. This question and this question is a similar model. This one and that one also. Make sure that you deal this. Two are రాయాలి ఇక్కడ. Thank you. Same, you can do this here. Now what will happen is, in the reference frame of the container, in the reference frame of the container, we have MA. And that is a maximum theta. There instantaneous rest. It comes to instantaneous rest. Remember when it started here, that time also U relative 0. Here also V relative 0. Initial velocity 0, final velocity 0. Did you notice that? But again, the same situation. I don't see any difference between that problem and this problem. I am apply work energy theorem in the reference frame of the container. Okay. Now this will become MAL sin theta. MAL sin theta, work done by pseudo force. See, first time when I have done, I have written every step properly. Now you know how to do. So I am substituting. Work done by gravity minus MGL 1 minus cos theta. This is the net work done. Apart from this, there is no other work. But net work done is change in kinetic energy. What is the change in kinetic energy? Zero. Why? Initially rest, finally rest. So that comes around, you will have a situation. MAL sin theta is MGL 1 minus cos theta. ML, which implies A sin theta is by a 1 minus cos theta can be written as 2 sin square theta by 2. Now I am extending this here. Sin theta can be written as 2 sin theta by 2 cos theta by 2. This is 2g sin square theta by 2. Finally, tan theta by 2 is A by G, which implies theta maximum is nothing but 2 times tan inverse A by G. Any doubt in this, please ask. Boys and girls, do you have any doubts in this? Got the point? Sure? Right. నీ ఇష్టం ఏసీ రిమోట్ వాయిస్ దగ్గరికి ఇవ్వండి ఫస్ట్ ఎఫెక్ట్ అయ్యేది వాళ్ళే చూడండి అసలే మా సిఓ స్కూల్ బాయ్స్ నేను 1 ఇయర్ నుంచి పెంచుకున్నాను వాళ్ళు నా చేతులు ఎన్ని తిట్లు తినుంటారు ఒకడో ఇద్దరు దెబ్బలు కూడా తినుంటారు ఎవడు బాగుండే విషయం ఎవరు రాడు బీసీసీనా ఫస్ట్ ర్యాంక్ వాడికే వస్తుంది నాకు తెలుసు నెక్స్ట్ రైట్ ఇప్పుడు ఈ మోడల్స్ కొంత ఆపి ఇవి చేద్దాం కొంత ఇది చేద్దాం ఇవి చేద్దాం ఫండమెంటల్స్ చేసి వెనక్కి చాలా అప్ టు యు. Block of mass M is suddenly released from the top of a spring of stiffness constant K. So, this is a spring of stiffness constant K. Find the acceleration of the block just after the release. See, try to please understand what happens just after the release. Nothing. It still experience weight force. Immediately after the release, it will still experience weight force. Except that there is no other force. Only when some compression happens, spring exerts force. Now, for example, you take the situation like this. That is the spring. Okay. And we call this as relaxed length of the spring. At this stage, spring is relaxed. At some point of time, when the block is here, mg. Some point of time when the block is here, mg, force acting downwards. By that time, say it has compressed by an amount y. So therefore, the spring will experience it may have an acceleration A like this by that. Two forces. When it reaches, what is the meaning of equilibrium? Equilibrium is the stage where, yes, the block will experience zero acceleration. When acceleration is zero, that is called equilibrium. In that case, what will happen is, we will call this as some y naught. At this point, ky naught mg, correct. Ky naught becomes equal to mg. That is the equilibrium. Remember, at this stage, the block will have maximum velocity. At the equilibrium position, the block will have maximum velocity. Sir, how can I measure the maximum velocity? Very simple. Apply law of conservation of energy, these two positions. Let this be position A. Let this be position B. At A, what is the total energy? We will call, what is that? We will take reference is the ground like this. mg L0, that is the only form of energy. Even spring don't even have any compression during that time. That is the only form of energy. So at B, what are the different forms? At B, the height is mg L0 minus y0. Plus, there is some energy in the form of compression, half k y0 square, plus half m v maximum square. So with this, I can write half k y0 square minus mg y0 plus half m v maximum square is equal to 0. Don't forget to use this. Y0 is nothing but mg by k. So k y0 square is nothing but m square g square by 2k. Correct? Minus mg y0. It is nothing but minus mg square by k plus half m v maximum square. Half m v maximum square is equal to mg square by 2k. So with this This is equal to, what is this going to be? Root m by k times g. Okay, that is V maximum. Writing is not clear. G. That is the expression for Vmax. Another case is also possible here. Maximum compression case is also possible. You know what I have derived here? Maximum velocity condition. ఇప్పుడు నేనేం కండిషన్ డెరైవ్ చేస్తున్నా? మాక్సిమం కంప్రెషన్ కండిషన్ డెరైవ్ చేస్తున్నా. సో మాక్సిమం కంప్రెషన్ కేసులో ఏం జరుగుతుంది? అదిగో బ్లాక్. ఇది L0, ఇది L0 మైనస్ వైమాక్స్. ఇంకోటి వైమాక్స్ దగ్గర వెలాసిటీ బికమ్స్ 0. But force and acceleration is not 0. It will experience maximum acceleration upwards. Now again, we will call this as A and we will call this position as C. So what condition I am deriving now? Maximum compression condition. Now tell me how to handle this. Yeah, initial energy is mg L0, final energy is mg L0 minus Ymax. Potential gravitational potential energy వచ్చేసింది. Spring half k Ymax square plus kinetic energy 0. లెఫ్ట్ హ్యాండ్ సైడ్ మరి నేను స్ప్రింగ్ రాయాలా, కేఈ రాయాలా? ఎందుకంటే యూఆర్ రిలీజింగ్ ఇట్ ఫ్రమ్ రెస్ట్ కదా. సో యాక్చువల్గా ఇక్కడ ఏం రాయాలో తెలుసా? వాస్తవానికి 0 + 0 రాయాలి. ఎందుకు? స్ప్రింగ్లో లేదు, కైనెటిక్ ఎనర్జీ లేదు, ఏమవుతుంది? నౌ ఫ్రమ్ దిస్ యూ కెన్ రైట్ half ky maximum square is equal to mg Ymax. SI. So therefore Ymax is 2mg by k, which is nothing but 2y0. Remember, this is true only when the block is released from rest. This is true only when block is released from rest. Yeah. Now you please tell me, do you have any doubt in the entire derivation part? So I have derived two things there. One is maximum compression condition. The other is maximum velocity condition. Now if you want the acceleration of the block at the maximum compression, yes, I am prepared to give you. What is that? Now draw the free body diagram properly. You try to draw the free body diagram. What are the different forces on this? One is a ky max. The other is mg. So ma max is ky max minus mg. అంతేగా? So which is ky max వచ్చేసి మీకు ఏం వస్తుంది? Ymax 2mg by k ఉంది. ky max ఏమవుతుంది? 2mg minus mg, which is equal to mg. So A is g upwards. When you release it, it is g downwards. At maximum compression stage, it is G upwards. Any doubts? If you give up now, all spring models will be a difficult task for you. If you give up now, I'm telling again, all these models will become difficult for you. It's a fundamental model in springs. Let me see any other models. Yes, it's an excellent question actually. నేనేం చేస్తానంటే రైట్ please go through this question. Please go through this question. If you are capable of answering this question, that's all. You have understood the spring concept properly. Try this. Here, unlike the previous models, you have friction. See, read this. They have clearly mentioned rails offer this is a term which is very important. After rebounding from the spring, the mass rises back, but could only reach a position delta H below the starting position. Delta H is given. Find the maximum compression caused in the spring. For this problem, my basic stepping mechanism is you need to understand that there is loss in mechanical energy. Undoubtedly, there is a loss in mechanical energy due to friction. This is the first observation one must have. Loss in mechanical energy due to friction. Second point. The entire loss is due to friction only, right? I am assuming let X refers to maximum compression in the spring. So I would like to explain this like this. So this is the initial position. And let this be X. This is the final position. Remember, in the process, This is the maximum compressed state. Maximum compressed state. And again, you are reaching back to a situation somewhere over here. Delta H. That is the final state. Nowhere spring is linked actually here. What is the, in this process, initial to final? Okay. What is the distance traveled by the mass? First H plus X down, maybe H plus X up, and again delta H down. So total it is actually I should write this in a different way. Downward direction H plus X, upward direction Hx plus H minus delta H. This is during upward motion. This is during downward motion. This you can write as 2 times H plus X minus delta H. Any doubts till this point? H have they have given H as well as they have given delta H. So 2 times 1 plus X minus 0.2. So finally this is 1.8 plus 2x. Friction does a constant work here. Yes or no? So what is the work done by the friction? All the time it does negative work. Friction opposes relative motion. So therefore minus of F into 1.8 plus 2x, which is nothing but minus 50 by 3 times 1.8 plus 2x. Right. So here, what, from my point of view, what is the total loss in mechanical energy? It's simple. Earlier you are at a height h, now you are at a height h minus delta h. So mg delta h. By the way, what is m? 20 kg. 20 into 10 into zero point 0.2. So 40 joules. So try to understand the loss in mechanical energy is nothing but 50 by 3 times 1.8 plus 2x is 40. Only thing that you need to do is you need to do some calculation part. This will become 5 times 1.8 means 9. 9 plus 10x is 12. Implies x is equal to 0.3 meter. So finally, what I have given you is the compression in the spring as well as the work done by friction. Whatever you want, I have given. Very good question. Now, if you have any doubt, just question. Whatever you have a doubt, just question. Boys and girls, do you have any doubt? Yes. అది రెండోది కలిపి ఒకటే చోట ఫ్రిక్షన్ ఉంటే ఈక్విలిబ్రియంలో ఉండదు, అంటే రొటేషనల్ ఈక్విలిబ్రియంలో ఉండదు. ఓకేనా? రైట్. నెక్స్ట్ స్ప్రింగ్ మోడల్స్ ఫస్ట్ కవర్ చేసేద్దాం. రైట్. షెడ్యూల్లో నెక్స్ట్ block attached with a spring is kept on a smooth horizontal surface. Now the free end of the spring is pulled with a constant velocity u horizontally. Then the maximum energy stored in the spring and the block system during subsequent motion is. See, then the maximum energy stored in the spring. See, try to please understand what exactly is happening over here. Now, this is always moving with a constant velocity. When both the ends of a spring have same velocity, spring is maximum elongated. That is the question. Suppose if I am doing the problem in the reference frame of this. So the instant, what will happen initially? You will see that this will have some velocity u. And remember, you always see that this will always have some u velocity. As a result, what will happen? Spring keeps elongated. Spring reaches a maximum velocity, and thereafter you will notice that at some point of time you will notice that. 1 minute. A small clarification. Actually, the syllabus related to springs are next week actually. Okay, no issues. I'll close this question. Anyway, next year, anyway, you need to prepare. Anyway, next week, you need to prepare. So some part of this will be covered now. Please try to understand here mechanical energy keeps increasing. He is an observer moving with constant velocity. You said that very clearly in the question. So, in his point of view, all the time this block will have that speed. You in yes. Thereafter, what happens? True. Now, what is that we need to give is the observations that before I start the free body diagram, some observations I need to take. This is the first observation, anytime. Second observation that I need to post here is the mechanical energy part. Mechanical energy will keep increasing, up to the instant when there is a limit, when WF external is positive. Once it becomes negative, see, elongation, there won't be any compression or something like that. What is happening? First stage, spring will elongate. In the very first stage, spring will elongate. Thereafter, the maximum energy stored in the spring. So in the first part, the spring will be elongated. Thereafter, remains the same. And what if the work done by the spring is positive on the block? Nasi, please try to understand what is happening over here. Mechanical energy will keep increasing up to some instant when F external is positive. F external పాజిటివ్ ఎందాక అవుతుంది అనేది ఏ ఆస్పెక్ట్స్ మీద చెప్తాం మనం. స్టడీ చేయండి కేసుని. యు బీ అన్ అబ్జర్వర్ ఆన్ దట్ ఏ హియర్. నువ్వు స్టడీ. First, the spring will elongate. And thereafter, it attains natural length. Next, what happens? There is a compression, and thereafter, compression takes place. So the maximum energy when the spring in this point of view with respect to him, what is the velocity? Maximum compression phase. Because with respect to him, once it turns back, that is the situation of maximum compression or maximum, whatever it is. It is the maximum kinetic energy that is block kinetic. There actually, this is with respect to observer. With respect to ground, you know what is happening? Right. Now, the question is, what is the KE maximum of the system? Half m 2u square. This is going to be 2mu square. This is the stage where spring is relaxed. See, please try to understand. Initially, it's going leftwards, reaches in a instantaneous rest, and again move rightwards. And which means this is a stage 2. This is stage 3. So I need to draw stage 1 somewhere over here. Initially, what is happening is, in this case, stage 1 area, where I need to draw stage 1 space. The entire space allotted to me. Okay, right. Initially, it is moving like this. Stage 1. Thereafter, it comes to instantaneous arrest with respect to him. Thereafter, it turns back and moves in the direction of the motion. At this stage, it will have the maximum kinetic energy. And thereafter, what happens? The spring keeps compressing. The spring keeps compressing. Now, what is the total energy associated with you? 2mg square. The mechanical energy associated with you is 2mu square. Now, the entire energy, if it is stored in the spring, that is the maximum energy stored in the spring and block system during the subsequent motion. When the spring is relaxed, the block is having this much energy. Thereafter, what happens? The kinetic energy keeps decreasing. The spring gets compressed. And this cycle keeps happening. After this stage, what will happen is you will find a stage where the block attains some kind of velocity, instantaneous velocity 0, and the spring is maximum compressed likewise. So therefore, my point is very clear. In this point of view, you need to notice that this is the maximum kinetic energy. And this is the energy stored possibly in the spring. So very good question actually. Next, so springs are not there. We need to work on potentials only, right? Do this question. Chain of length L and mass M lies on the surface of a smooth hemisphere of radius capital R greater than L, with one end tied to the top of the hemisphere. Taking base of the hemisphere as a reference line, find the gravitational potential. This is a question even in H.C. Verma also you have this question. Now, in this case, what is going to happen is you need to find potential energy. Now you have this theta, no? This element is r d theta, right? What is the potential energy of an element? This is, I will define a term called lambda, mass per unit length. You said the total length is L, mass per unit length. So potential energy is lambda r d theta, lambda r d theta m g or cos theta. MGH. Another H. Sure. ఉండదు అంత తీగ ప్లెయిన్ గా కూడా వెళ్ళకూడదు. కొంత ప్రీవియస్ మెయిన్స్ కొంచెం చేయించుకుంటారు అనుకోద్ది. హెచ్సి వర్మాలు అవి అంటే మెయిన్స్ హెచ్సి వర్మాలు కొన్ని క్వశ్చన్స్ అవి చేస్తే ముందు కాన్సెప్ట్ వస్తుంది, తర్వాత లెవెల్ 2 లెవెల్ 3 గట్టిగా చేయిస్తే సరిపోతుంది. స్టీర్కే చెప్పేది The concept నేర్చుకోవాలి. Building అంతా నేను చూద్దాం వెళ్ళిపోయి. నాకు చూసాను. నెక్స్ట్ చూద్దాం. Depends what we expect that. I do get my. Right. Therefore, in this case, lambda, right, potential energy of an element is this only one element. So, what is the total potential energy? Integration part of all these things. Lambda r square g cos theta d theta. This is nothing but there are limits here. Theta is from 0 to, see, please try to understand when this is of length L, this is of radius R, L is equal to R theta. Kada? Therefore, that is L by R. So now you can write this as a lambda R square G, integration of cos theta becomes sin theta, sin times L by R. Lambda is M by L R square G sin times L by R. This is the total potential energy of the system. Any doubts? Are we clear? ఒక్కోసారి ఇదే క్వశ్చన్ ని వాళ్ళు ఏమని అడుగుతారంటే, ఫర్ ఎగ్జాంపుల్ దే విల్ ఎక్స్టెండ్ ద సేమ్ క్వశ్చన్ లైక్ దిస్. అరే అన్నెసెసరీగా స్ప్రింగ్స్ మనం డిస్కస్ చేస్తాం. బాగుంటాయి స్ప్రింగ్ మోడల్స్. See, same question, what will happen is sometimes, now you see the situation like this. Now this has turned by an angle phi. It has turned by an angle phi. Of course, even now the angle is basically L by R. That is still L by R. So how to handle? No, it will have some key. So how to do that? Now only simple. What is the potential energy initially? We just have written the formula M by L G R square sine L by R. What is the potential energy finally? Very simple. I don't do any different thing. I'll just modify the integration. How to modify the integration? The integration step. Theta is equal to phi to phi plus L by R. అంతే కదా. You defined theta as 0 here. Now what is this angle? Phi plus L by R. Cos theta d theta. So what is this going to be? M by L G R square sin phi plus L by R minus sin phi. So loss in potential energy is gain in kinetic energy. So therefore, I'm going to substitute the same M by L G R square sin L by R minus mg R square by L sin phi plus L by R minus sin phi is half m v square. That is how I will find kinetic energy. Any doubt? Ena nayan on that? ఎంజిఆర్ స్క్వేర్ అది ఎల్ మార్కర్ అట్ట పడిపోతుంది. ఫాస్ట్గా రాసేటప్పుడు ఇది డిజిటల్ ప్యాడ్ అట్ట పడిపోతుంది. రైట్. ఎనీ డౌట్? నెక్స్ట్ ఇది కూడా చూడండి ఒకసారి. పొటెన్షియల్ ఎనర్జీ బేస్డ్. So what is the total potential energy initially? Now it is at a height, center of mass is at a height of A by 2. So the potential energy initially is mg A by 2. Now what is the height? mg B by 2. Total work done by external agency plus work done by conservative force plus is 0 because you are slowly lifting. There is no K gain. Work done by external agency plus what is the work done by conservative force? Minus of U final minus U initial, and there is no non-conservative force here. So the external force here is simply U final minus U initial, which is nothing but mg by 2 times P minus A. It's a very simple observation. Okay, clear? Right. Spring unnecessary గా చేసుకున్నాను ఇవాళ. Right, no issues. Ah, ah, take this. Force acting on a particle in a two-dimensional XY space is given as F bar is equal to 3 xi cap plus yj cap. అసలు ఇది ఎలా ఉందో తెలుసా మీకు? ఇది అంటే కొంచెం అర్థం చేసుకుంటే F bar is 3r bar by r cube, where r bar is xi cap plus yj cap. అసలు ఎప్పుడైనా ఏదైనా ఫోర్స్ ఈ కండిషన్ ని సాటిస్ఫై చేస్తే దీన్ని సెంట్రల్ ఫోర్స్ అంటారు. ఎఫ్ ఈజ్ ఏ ఫంక్షన్ ఆఫ్ ఆర్ అయితే చాలు, అది ఆల్వేస్ డైరెక్టెడ్ టువర్డ్స్ ఎ పాయింట్, ఇది సెంట్రల్ ఫోర్స్. సో సెంట్రల్ ఫోర్స్ ఆబ్వియస్గా చేసే వర్క్ జీరో ఎప్పుడూ కూడా. సెంట్రల్ ఫోర్స్ అయితే చాలు, సెంట్రల్ ఫోర్స్ అయితే కన్జర్వేటివ్ ఫోర్స్ అయిపోతుంది. ఆల్వేస్ డైరెక్టెడ్ టువర్డ్స్ ఎ ఫిక్స్డ్ పాయింట్ అయితే చాలు. ఇది అంటే ఏది సింపుల్ అండి. మీరు ఆల్వేస్ పర్పెండిక్యులర్ టు ద పాత్ అనుకోండి, సర్క్యులర్ ఆస్పెక్ట్లో తిప్పినప్పుడు క్లోజ్డ్ పాత్ జీరోనే కదా అది. మీరు నమ్మరు. సెంట్రల్ ఫోర్స్ అయితే చాలు, అసలు ఇంక అసలు ఏం ఆలోచించాల్సిన అవసరం లేదు. డెల్ బార్ క్రాస్ ఎఫ్ బార్ జీరో అయిపోతుంది. నమ్మం. ఓకే, ఏం పోయింది ఇప్పుడు? మీరు మళ్ళా దాన్ని మీరు డో బై డో ఎక్స్ ఐ క్యాప్ ప్లస్ డో బై డో వై జే క్యాప్ క్రాస్ 3 times x by x square plus y square whole to the power of 3 by 2 I cap plus y by x square plus y square whole to the power of 3 by 2 j cap. అది సెంట్రల్ ఫోర్స్. డెల్ బార్ క్రాస్ ఎఫ్ బార్, ఐ క్యాప్ క్రాస్ ఐ క్యాప్ జీరో అయిపోతుంది. ఆ డో వై బై డో ఎక్స్ కింద ఏదైనా ఏడవనివ్వండి, ఈ డో వై బై డో ఎక్స్ జీరోనే కదా. అలానే దీని దగ్గరకు వచ్చేటప్పటికి డో బై డో వై ఆఫ్ ఎక్స్ జీరోనే కదా. ఇది జీరో అయిపోతుంది. ఇది చెక్ చేసుకునే పద్ధతి. మీకు నేను అసైన్మెంట్స్ కూడా ఇచ్చాను, కొన్ని క్వశ్చన్స్ దీని బేస్డ్ మీద. ఇది ఒక్కసారి చూసుకోవాలి కూడా మీరు. ఓకేనా? రైట్, మంచి క్వశ్చన్ ఇది. సెంట్రల్ ఫోర్స్ బేస్డ్ మీద కొన్ని క్వశ్చన్స్ నేను అసైన్మెంట్లో కూడా కొన్ని ఇచ్చాను. ఒక క్వశ్చన్ కంపల్సరీగా వస్తుంది దీని మీద. ఓకేనా? ఇదే క్వశ్చన్ కనుక వైఐ క్యాప్ ప్లస్ ఎక్స్ జే క్యాప్ ఇస్తే నాన్ జీరో. వైఐ క్యాప్ ప్లస్ ఎక్స్ జే క్యాప్ వచ్చింది అనుకోండి, అది నాన్ జీరో. అప్పుడు అది సెంట్రల్ ఫోర్స్ కాదు. ఓకేనా? అప్పుడు అది నాన్ జీరో అయిపోతుంది. సేమ్ క్వశ్చన్. ఓకే, నెక్స్ట్ వీక్ చేద్దాంలే. 1 minute. 45. Try. పవర్ బేస్డ్ అయితే నెక్స్ట్ చూద్దాం. పవర్ కూడా నెక్స్ట్ వీకే. ఇచ్చేసుకోండి. ఒక్క నిమిషం ఆగండి, ఇది నేను హైడ్ చేస్తాను. ఇంకా అలాంటిది ఏమైనా ఉంటే నాకు చెప్తాను. వినిపిస్తుంది. రైట్. ఓకే. ఇది కూడా కొంత పవర్లోకి వస్తుందిలే కానీ, బట్ అన్నీ ఇప్పుడు ఇది నెక్స్ట్ వీక్ దాకా పోస్ట్ పోన్ చేస్తుంది తప్ప ఈ క్వశ్చన్ వచ్చేసింది అనుకోండి, నాకు కొంచెం కష్టం కదా. Plank is moving along a smooth horizontal surface with a constant speed v. Block of mass m is gently placed on it. Initially, the block slips and then acquires a constant velocity v, same as the plank. Throughout the period, the horizontal force is applied on the plank to keep its speed constant. Find the work performed by the external force. ఇక్కడ మీరు నోటీస్ చేయాల్సింది ఏంటంటే, it is like a conveyor belt model. మీరు ఫ్రీ బాడీ డయాగ్రామ్ ఆఫ్ ద బ్లాక్ తీసుకోండి. అందరూ ఫ్రీ బాడీ డయాగ్రామ్ ఆఫ్ ద బ్లాక్ తీసుకుంటే యాక్చువల్గా ఇది ఫ్రిక్షన్. ఫ్లాంక్ తీసుకుంటున్నాను. ప్లాంక్ మీద ఇదే రియాక్షన్, యాక్షన్, రియాక్షన్ ప్లస్ నువ్వు కొంత ఫోర్స్ అప్లై చేస్తున్నావు ఎఫ్. ఇన్స్పైట్ ఇది కాన్స్టెంట్ వెలాసిటీతో వెళ్తుంది. Now let us say slipping stops in t seconds, because after t seconds, block as well as the plank, block block and the plank, they move with same velocity thereafter. After t, there is no slipping. Now please try to understand, after t seconds, this block will have v velocity. F into t is mv, momentum impulse theorem. Correct? So therefore, whatever is v, that is f into t by m. Ikkada, this system is always moving with constant velocity. Means, in this case, v constant To maintain V constant, F and small f must be the same. So therefore, this is F into T by capital F. I think till this point, there is no issues for you at all. So what is the work done by external force? What is the work done by external force? In time t. See, this can be written as literally what is the work done by the external force. Okay, by the way, what is the displacement of this part? Displacement of this part is half AT square. Indaga. What is the displacement of the lower part? Simply Vt, because it is moving with constant velocity. So therefore, if you ask me what is the work done by the external force, I'll simply say Fs2, F into Vt. But F can be written as mv by T into Vt, which is nothing but mv square. By the way, what is the heat developed due to friction between the block and the plank? I can easily answer this. Kinetic energy of upper block is simply half mv square. Correct? Are you have worked, total work done is half mv square. Work done by external agency plus work done by non-conservative force plus work done by conservative force is change in K. Work done by external agency mv square. Work done by non-conservative force, I don't know. I need to find that. There is no conservative force. What is the change in K? There is no change in K of the plank. Correct? There is only change in K of the block. So therefore, work done by non-conservative force is mv square minus mv square. Minus mv square by 2. ఎప్పుడైనా non-conservative minus అంటే loss. So therefore, heat loss is mv square by 2. This is an excellent question. Please try to convince me that, just confirm me that whether you understood this or not. Suppose if the nature of the friction is static, there is no loss. The nature of the friction here is kinetic. So you have loss. Got the point? Pakka? Sure? Right. ఇది ట్రై చేయండి ఒకసారి. ఇంకా నేను ఏమేమి చూసుకోవాలి. ఇప్పుడు చిన్న థియరీ పాయింట్ You have an inclined plane, fixed inclined plane like this. And you are slowly moving the block up. So in all these cases, the friction here is what is the work done by friction here? L stands for the length of the inclined plane. Can you please tell me what is L cos theta? L cos theta is nothing but the total length of the base. So simply minus mu mg x. You can use the same concept even on such rough surfaces also. But the condition is it should be slowly moving up. That should be slowly moving up. Every portion is an inclined plane for me. I'll take the projections of all such inclines on the base. So finally, what I will get? Simple. This is x. In this case also, work done by friction is minus mu mg x. Remember, this is true only when the object is moved slowly up. Otherwise, normal reaction won't be mg cos theta. It will be more or less because suppose if it is a curved surface, concave type or convex type, normal reaction will change. This is the concept which I am going to use in my next question. So this is the basic which I have given you right now. Okay. This concept is required for me next question. '86. A small object is sliding on it's a smooth horizontal floor along a vertical wall. You see the wall structure there. Now here you choose a point P over here, a point P. What I'm telling you is, let me draw a tangent here. This is a tangent drawn at P. What is the significance of this tangent? This is the instantaneous velocity vector. Friction, exactly opposite to this. Friction is exactly opposite to this. Remember, this might be some curved surface. For this purpose, at this point, this is how your normal reaction force will be. Remember, it started here. From here, curvature starts. Now you extend this. At that point, this is O. And let this be small angle theta. So from here, you have just turned by an angle d theta. And let at this point the radius of curvature is r. So the normal reaction at this point is mv square by r. Any doubt? You know already, because pseudo force concept. Okay. Now what is friction? Friction is nothing but mu n mu mv square by r. What is work energy theorem? Net work done is change in kinetic energy. Right. Okay. At that point, the small work done. See, remember, try to please understand the small work done is minus mu mv square by r into r d theta. This is a small change in kinetic energy, which is nothing but mv square by 2 ని డిఫరెన్షియేట్ చేస్తే మీకు ఏమొస్తుంది mvdv హాఫ్ mv స్క్వేర్ డిఫరెన్షియేట్ చేశాను నేను రైట్ సో వాట్ ఈస్ దట్ యు ఆర్ గోయింగ్ టు గెట్ హియర్ రైట్ right. So what I got is dv is minus mu v d theta. dv by v is minus mu d theta. Here you projected with initial speed, say some v naught. At some instant, the velocity is v. The speed of the object before the turn is u, you said. Some instant v. You just have turned by an angle theta naught. So log ev by u is minus mu theta naught. So therefore v is u times e power minus mu t. Do you know this? Log ep is equal to m, for example. P can be written as e power m. Same thing. So your function is u e power minus mu theta naught. I've simply applied work energy theorem. Work energy theorem not for full length of the part. It is small elemental part. It is small element of the path. That's all. Okay. So go to your class.